Today, we'll explore how the law of cosines can help solve real-world problems, specifically in navigation around a tropical storm. The law of cosine states that in any triangle, the square of one side equals the sum of squares of the other two sides, minus twice their product times the cosine of the included angle. Let's consider a ship that needs to navigate around a tropical storm. The ship is currently at point A and needs to reach its destination at point B. However, there's a tropical storm at point C that the ship needs to avoid by staying at least 200 nautical miles away from it. The ship's navigation system shows that it is 300 nautical miles from the storm, and the destination is 400 nautical miles from the storm. The angle between these two positions, as seen from the storm center, is 120 degrees. To find the direct distance between the ship and its destination, we can apply the law of cosines. Let's substitute our values. C squared equals 300 squared plus 400 squared minus 2 times 300 times 400 times the cosine of 120 degrees. First, let's calculate the squares. That's 90,000 plus 160,000. Next, for the last term, we know that the cosine of 120 degrees is negative 1/2. So negative 2 times 300 times 400 times negative 1/2 equals 120,000. Adding it all up, 90,000 plus 160,000 plus 120,000 equals 370,000. Taking the square root gives us approximately 608 nautical miles. Now, we need to verify if this direct route would keep the ship at a safe distance from the storm. We can find the height of the triangle, the shortest distance from the storm to the ship's path, using the formula. Height equals the product of adjacent sides times the sine of the included angle divided by the length of the opposite side. Plugging in our values, height equals 300 times 400 times sine of 120 degrees divided by 608. This gives us approximately 260 nautical miles, which is greater than our required safe distance of 200 nautical miles. And there you have it. The law of cosines helped us determine that the ship can safely travel directly to its destination while maintaining a safe distance from the storm. This is just one example of how trigonometry helps solve real-world navigation problems.